If you're thinking of making birthday caps at your home using paper, have you ever wondered how much paper would you need? How can you find that out? Well, for that, we need to know the surface area of this cone. How do you find the surface area of a cone? Let's find that out. So here I have a cone. I've made a paper cone with the base, and let us try to find the area, the surface area of this cone. So we'll follow the similar approach as we've done with the previous two cases, the cuboid and the cylinder. So I take the cone. Firstly, let me tell you one thing. We will generally we try to um, define the variables before we start deriving any formula for any shape or in general anything. So I'll just define those two variables. So the variables I wish to use are, firstly, so what are the easiest things to measure of a cone? The base, the radius of the base circle, first thing, and this length. So what do we call this length? Obviously this is not the exact height, right? The height of any object is this. See, so if I measure the height, I would measure like its height this way. So the height would be this much, but I am measuring it this way. So uh, I have to slant the scale. So this is called the slant height of the cone. So if I show you on the side, this is the slant height, while this is the actual height. I'll just show, label it here. This is the slant height denoted by an L, and the actual height is denoted by an H, but we just need the slant height L. So if you are for example planning to make birthday caps, then to find the area of the total surface area, you need this length, the slant height, and the radius of the base area. So this, I'll just label it here as R. So let's begin. I'll first of all remove the base of the cone. I've removed the base of the cone. This is the top part of the cone, and if you have just this part, this is a hollow cone. And just like the cylinder, this is called the curved surface area of the cone. That is the base, and if you join both of them, you get the total surface area of the cone. So first, let's put that aside because the area of that is easier. So let's first start by finding the curved surface area of the cone. So it's difficult to measure this area. So what we can do is again cut the cone from the side to get a flat shape, and let's see what we get. So what we get is, this is a sector. If you don't know what a sector is nothing but, you can imagine a pizza and eating a few slices out of that pizza. What is remaining, or even a pizza slice itself is a sector. So the pizza slice that has been eaten is a minor sector, whereas this is a major sector. You don't need to know that. So this is a sector. The area of this sector is the area of the curved surface area of the cone. How do you find this? So that's the tricky part. So what we do is, we can actually divide this into smaller triangles. Obviously, if I make a large cut from here, I will not, for example, if I cut it this way, this is clearly not a triangle, right? This has a curved surface. This is itself another smaller sector. But if I cut a very 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 thin triangle, thin slice actually, see, now that is almost a flat surface. You cannot really tell the difference if that is curved or flat. So that looks pretty much like a triangle, right? So I can just do that for the rest of the shape, and yeah, I'll just cut it into smaller triangles. So there I've cut the whole curved surface area of the cone into small triangles. Obviously I could have gone even smaller, but being a human and I don't have that much time, I'll just cut these many triangles. But yeah, obviously you can divide them further into a much more thinner triangle. But yeah, you get the idea, right? These are all pretty good triangles. They don't look curved, they look flat at all the sides look flat. So now all I have to do is find the area of all these triangles, add them up, and I get the area of the sector, which is again the area of the curved surface area of the cone. What was that? So yeah, that was the remaining part here. I forgot to cut that. I'll just cut that. Yeah, so I've just cut that part. So yeah, I have to find the area of all these triangles, add them up, and I get the area of the curved surface area of the cone. How do I do that? Well, what is the area of one of these triangles? Let me choose this. So what is the area of a triangle? The area of a triangle is the base, that's the base, times the height into half. So area of one triangle, area of any one triangle equals half into base, I'll just write that as b, times height. What is the base of this? Let that be b. Okay, so if this is b, so b is its base. What is the height of this triangle? What is the height of this triangle? Well, if you remember, what we had done is we had the sector in this shape, right? And if you remember, the height of the triangle is actually the radius of the whole sector. Remember, because you've cut it into thin slices. So this is actually the radius of the sector that we had cut the curved surface area of the cone into. And if you remember, the sector's radius was actually the slant height. So this height of the cone. So this is actually, so if I pick one of the triangles, this is actually the radius or the height of this triangle is actually the slant height of the cone the cone that we just cut down. Okay, that was just an example. So I can write this as, I'll let the half be half into b, base of the triangle, times h, height of the triangle, which is actually the slant height of the cone, which is represented by L. And you can just see it somewhere there. Yeah, you can see I have drawn the line. So this line was actually the slant height of the cone. So the height of the triangle, all those triangles, is actually the slant height. So what is the area of one triangle? Half into b into L. Well, what is the area of all those triangles if we add them up? So I'll just write that as total area of all triangles equals, so that is half into b of this triangle times L. L is same for all of them. So b1, let's say, times L, plus half into, take the second triangle, its base, which is b2 for example, and its height is the same, L. So L plus, I'll just write it here. So this is in continuation, or I'll just write it here. This whole plus the next triangle, so its area is half into its base, b3, let's say, times L, its height, which is the same for all of them, and we can go on and on. Now so this way you can do it for all those triangles. I'll just write dotted there. And this total surface area of all the triangles is actually the total area of the sector, and that area was actually the curved surface area of the cone. So curved surface area, the total area of all the triangles is actually the curved surface area of the cone, is equal to, what I can do is, here is, so I can see the half common in all the terms, right? Half, half, half. So I can take the half common. Good. Then I see the L common in all of them. I can take the L common. So I get half times L. I'll make bracket. B1 plus B2 plus B3, and add all the bases of all those triangles. So if I open the brackets just to confirm, I get half into L into B1, half B1L, plus half L B2, half L B2, plus half So half L B3. So half L B3. So yeah, that's correct. Now what is the sum of all the bases of the triangles? Well, you can just look at that. If I position them this way, I'll just quickly position them. Okay, so I have aligned all those small triangles back again, and if you see the sum of all the bases, b1 plus b2 plus b3 plus b4 plus b5 plus this base plus this base plus all the bases of all those triangles, what do I get? I get this length. What is this length? This is the arc length of the sector. And if I see the cone, in a cone, what is this length? Well, if you see, this is the sector, right? I have folded this shape by joining these two ends and forming this cone. So what is this length? This length of a cone is actually this length of the cone, right? And what is this length? Well, this is this length, or this this length is actually the perimeter of the base circle, because they obviously join together. So this length here is actually this perimeter. So what is the perimeter? So what were we trying to find out? Just to think again. We were actually finding the sum of the bases of all the triangles. The sum of the bases of all the triangles gives me this length, and that is equal to this perimeter. So the sum of the bases, sum of all the bases of all the triangles is this length, which is, what is this? The perimeter of the circle, which is 2 pi r. So I can replace this by 2 pi r. What do I get? CSA equals half L, and replace this by into 2 pi r, and there I go. I get an expression which has only r and L as the variables. CS is what we are trying to find out. So I'll just cancel the 2, and what I'm left with is L into pi r. So I'll just write that here. CSA equals pi r L, and that is the curved surface area of a cone. Pi r L. Simple. Not very simple, but yeah. So we just found the curved surface area of the cone, and just to end it all, so we found this whole area. But if we had the complete cone with the base attached, what would be the area? The area of the curved surface area. So the total surface area of a cone, TSA, equals the curved surface area, this surface area, plus the surface area of the base, that would be on the at the bottom of the shape, plus this area. So I just said the base area, BA. You can hit anything, and the total surface area. So what is the curved surface area? Pi r L. Just found that out. Pi r L plus, what is the base area? That is simply, so the radius is r. So this area is pi r square. So the base area is pi r square. That is the total surface area. Again, we can take pi. So we pi both sides and r both sides. So we can take that common, just to simplify. And what we get is pi r times L plus r. And if we can just multiply pi r into L, pi r L, plus pi r into r, pi r square. So that is the total surface area of a cone, pi r into L plus r, and I'll just write that also. The curved surface area is pi r L. So that is it. We've just found the curved surface area and the total surface area of a cone. That's it. One last thing that I need to add here is, sometimes in some questions you won't be given the slant height L or L here. Instead you will be given the total height, which is this. So this height. So how do I find the slant height of any cone if I have been given the radius, obviously, and the actual height? So what is the actual height? So I can, if I show you it this way, the height is this much, right? I can use a scale to denote that. So the height of the cone is this much, and so this is the height of a cone. Well, I can draw that on the cone. So that height was this much. So if I just put it down flat on the ground, I get this as my height, h, and the slant height is obviously this, right? Just so this is the slant height. So I can draw that as this border as L, the slant height. And if you see, this forms a triangle, this being the radius of the bottom circle, right? This is the radius of the bottom circle. So if you see, if I show you, so this is the circle, the bottom circle, right? The radius of the bottom circle is this much, and if you see it this way, this is exactly matching with this. So this, the distance between these 2 points is r, or the radius of the base circle. So what I end up getting is a right angle triangle. So that is 90 degrees, right? Because, sorry, not that, that is 90 degrees. Why? Because r is parallel to the ground, whereas height is always perpendicular to the ground. So this should be 90 degrees. So this here is 90 degrees. L is the slant height, r is the distance, and if I apply the Pythagoras theorem to that, what I get is, so Pythagoras theorem says that the hypotenuse squared, in this case L squared, equals this side square, the perpendicular squared, plus the base squared. Or I can just shift the square from that to this, and what I end up getting is L equals under root h square plus r square. And that is how you find the slant height if you've been given the height of the cone and the radius of the cone. That's it for this video. Yeah.